Welcome our new speaker, Mofizur Rahman. Mofi is a developer advocate at IBM. He is learning and teaching Go, Kubernetes, Docker, microservices, and also writing technical blogs. Please welcome, and the stage is yours.
So welcome everyone to this session. If the name doesn't match or the title doesn't match, you are probably in the wrong room. But other than that, hopefully you're in the right room today. And we're ready to talk about end-to-end machine learning platform on Kubernetes with just a few clicks. So if you want to follow along and find the slides, the link to the slide is this slide. So the link is tiny.cc/E2E-ML-K8s. So once again, it's tiny.cc/E2E-ML-K8s. So not too long ago, we can all remember machine learning and AI was a novelty, right? Like companies were spending a lot of time and spending a lot of money researching a lot of this machine learning ideas. And it was not necessarily a core part of your business. Some companies were doing it well, some companies were doing it a little bit more sporadically. IBM, where I work at, even 10 years ago, machine learning was a huge research topic, and we were spending hundreds of millions of dollars every year, but it wasn't directly making any business impact. It was more of a theoretical side of business where you have a lot of data, you just don't know what to do with them, and you just try different things out. You try to gather some information from the data. Well, if you look at the whole machine learning ecosystem, there's a lot of different things that needs to happen for machine learning code to become useful, but most of the effort is still spent on that small, tiny block in the middle, machine learning code. Engineers love, data scientists love their machine learning code. We write a lot of code in Python, R, and like TensorFlow and all of these things. We're just like spending a lot of time in the middle, where to make your machine learning code valuable, you actually need to spend a lot more time on the things around it, right? You need to spend time on data verification, analysis. You need to serve the model you create. You need to monitor the model so that you know the thing it's doing, it's the right thing to do. So now, more and more, it is a core part of every business. So just the machine learning code is not good enough to be able to serve the underlying business is trying to improve by using machine learning and AI. Data is everywhere. We generate more data now, more than ever. And understanding what that data is and what that data means is more important than ever. It's estimated in the next 10 to 15 years, our data ingestion and data creation will quadruple or like go to an exponential number. But if we don't understand what data means, that data means to us, we are just like wasting time and money by generating more data. We're not actually getting anything valid out of it. So with that, I think because machine learning is becoming more and more mainstream and becoming more and more core part of our business, comes the rise of ML ops. If you're not familiar with what ML ops is, well, you can ask, what is ML ops? So ML ops is the ability to apply DevOps principles to machine learning applications. And this is the definition given by the ML ops special interest group from Citi Foundation. So what MLOps is trying to solve is that right now, machine learning, even to this day, in a lot of companies, in a lot of organizations, is a sporadic thing. It's done by a data scientist. It's almost treated like research. It's done almost as in an educational capacity. And we want to make that into a core part of your model. If you're building software in 2021, I'm hoping you have embraced some of the DevOps practices where you have your code is being continuously tested, your code is being integration tested, then your code is going through some sort of deployment, continuous delivery model where your code goes to your version control, then gets tested, gets built, gets pushed to production, gets tested again, and you can have rollback and all that features. And MLOps is trying to bring those same principles into the lifecycle of your machine learning models as well. Well, with that introduction, I am Mofi. I'm a software engineer and developer advocate at IBM, and I mostly do container things. So if you haven't figured it out by now, I am not from this world of machine learning. I'm not coming into this from the perspective of a data scientist. I come from the world of infrastructure and containers. Most recently, I have been contributing to the Keyflow upstream project into the manifest and deployment special interest group. And if you need to find me in a social media later, I can be found at Mofizur in any of the social media above, mostly Twitter. So if you have any questions after the conference, you can reach out to me. Feel free to reach out to me at Mofizur in Twitter. So the title of the talk talks about end-to-end machine learning platform. So what does that even mean, and why do we care about an end-to-end machine learning platform? So end-to-end machine learning platform, without going deeper into what it means, let's just talk about what we want an end-to-end machine learning platform to have. And when we say end-to-end machine learning platform, we're talking about something that covers everything from the start of the data to actually using that model into something useful in our application, in our business. The very first step, or even like one of the earlier steps, is data ingestion, right? So you have data being produced either by you collecting the data from your application, or user just sending you data, or by some other means, you're just collecting some data. And this is the part a lot of companies are still in, right? There's some graphs, and machine learning and data analysis actually stops for a lot of people at that stage. But if you want to do anything useful with the data, if you want to build some intelligence around the data, you need to take that data and clean it up, transform that data into something usable, validate the data so that you know that this data makes sense for your larger subset of the larger structure of the whole data. Then you are just putting the data for training, you're building models, you're validating models and training that model into like a distributed training to create this model that you can use. And this is where we see a lot of the gaps in like the theoretical structure of machine learning versus the business use cases that we have. Oftentimes data scientists are building these models, building this training into their own machine, and then testing out that this works. This is great, but the true value of machine learning only can happen when we are serving that model, like rolling that out into our application, using that intelligence, and then continuously monitoring that model's performance and logging that out and making that a whole loop, right? We're not just stopping at, oh yeah, I have built a model, great. Now our problems are solved. We actually now have to say, we have built a model, we're serving this model, we're getting information from the serving that the data we are getting makes sense, the performance makes sense, we're continuously improving that model. So an end-to-end machine learning platform ideally would give us all these things, right? And some parts it will probably do better than others. And you also want to make sure that we have a way to continuously improve. So end-to-end not just means that we have all these features and we're good to go. I think end-to-end should give us a way to continuously improve in each of those steps. So there are many commercial end-to-end machine learning offerings out there, and almost all major cloud providers has one. Other than that, you also have a bunch of third-party companies just providing machine learning platform as a service you can use. For example, you have Google Cloud AI Platform. I happen to work for IBM. We have a couple. We have IBM Cloud Pack for Data, Watson Studio. AWS happen to have SageMaker and many other services. And you have Azure Machine Learning Platform. And again, as I said, there are many more third-party companies providing this as a service. The pros of using end-to-end machine learning platforms from one of the cloud providers would be it is fully managed. You don't have to do all the bells and whistles are included with it. It works well with other cloud services. So if you are already a customer of Azure, using the Azure's machine learning service will work pretty well with the other Azure services that you have, like Azure Pipelines and like Azure Kubernetes, and all the other things will kind of like work together. And the same goes for any other cloud services. And because you are already with a major cloud provider, your machine learning platform itself is also cloud scale. You have an easier time just scaling everything up. And you also have enterprise support, right? You are working with a cloud provider and you are taking an enterprise plan. you definitely have a lot more support with it. So if something goes wrong, you have someone to talk to or get support from. Some of the cons, I would say, of an end-to-end machine learning platform that if you are going with a cloud provider in this sense, it's going to be expensive, obviously, because it's a pretty hefty costs you have to consider if you want to go down that route. You definitely have the chance of getting vendor locked in. One of the reasons that would happen is you are not necessarily doing machine learning, you're doing AWS machine learning. You're not necessarily doing right. So if you're whatever vendor you go with, you will have a version of, okay, we are doing this tool that Google thought that's how it should work. Then you build your infrastructure around it. And at some point you find out that you can't change it without having major rework if you want to move out to someone else. So you have this problem of vendor lock-in. And because your environment is managed by the cloud, it is not always super clear how you could have a local environment that replicates exactly how the cloud environment works. Oftentimes, some of the components are not even open source, so you have no idea exactly how they work under the hood. So you have to kind of do everything on the cloud, or you can do something on the local machine. Then you run the risk of not having a matching environment between cloud and local. Obviously, many of those tools are not open source in the vendors, so you don't really have a way of kind of doing it on your own or having a look at the source code or improve the code. If you see anything problematic, you are kind of dependent on the cloud to continuously make that improvement. And code and models are usually most of the times are not portable because you're building them in the cloud with their proprietary software. So it's going to be difficult for you to take your code and model and do it somewhere else. It's not true for every provider and not every cloud, but there's a high chance in a managed environment that could happen. So why not DIY, right? Like a lot of open source tools are out there. TensorFlow is open source. There are a bunch of other things if you look at the whole end-to-end things that you need, many of the tools that are out there that are open source. So definitely you could do something yourself using the open source, or it is also possible for you to write everything from scratch. And it is not the first time in the industry have done so. Companies like Uber, Netflix, Airbnb, Lyft, and many more have actually rolled out their own solution internally. I think Uber has a software called Michelangelo, and that kind of covers very Uber-specific problems and in a very Uber-specific way. It just solves those machine learning problems by building a whole entire platform internally at Uber. So good. If you are going down that route, some of the pros you can look at is you have full control over the platform, right? You are building the platform for your company and your exact needs. So everything you will build would be custom made for you. So because it's owned by you, usually you would not have any vendor lock-in, right? You would decide exactly how you can run it. Even if you need to switch cloud providers, I think because you own the software and the platform itself, you will just need to pay for the infrastructure if you're not running in your own data center. And it's customized to your needs. So this would, at least initially, would feel like this is the perfect solution because you made that solution for the problem at hand. But some of the cons are it's expensive. So although it might be less expensive because you are not paying for the service itself, but the engineering hour you would spend in building something ground up like this would be pretty expensive over time to manage. And you are on the hook. If something goes wrong, this is a service you made. You have to make sure it is up to date with the latest things. And as things change, things progress, you will have to have a continuous upkeep of engineering hours to make sure this thing is up to date. So as time passes, a platform becomes harder and harder to manage because you build a platform to do some machine learning for your business. You end up managing the machine learning platform, and now you don't have time to maintain your business. So there are some difficulty with DIY as well. Now, let's take a step back and think what we would want from a perfect machine learning platform, end-to-end machine learning platform, right? So number one is it should be built on scalable infrastructure. It should be something that can scale to whatever we need it to scale to. it should use existing tools data scientists already use. So we don't want to make sure we create something so new that our data scientists have to like have a huge learning curve and learn new things again. Ideally, and at least in my opinion, should be open source. So we know the community itself is improving and like taking the project forward that we use, that we depend on. Supported by the industry, we want to make sure that not only we're not the only person using it, that's good for us to get long-term support. Also, it's good for us to get long-term talent that knows these tools. Enterprise support option. So of course, we should have the option to DIY, but you also want to make sure that even when you are ready to go to the route of, I want to just pay some company to deal with this, some of the management issues, you want to have that as well. And finally, it should be portable. Your machine learning models and your code should be portable for you to take anywhere you want to take it. Well, a lot of the things, and again, I probably gave it away early on, is this Keyflow. Is Keyflow the tool that covers all of this end-to-end machine learning needs that we have? And I would like to think that is it, right? So, and now we're going to talk about how Keyflow fits all of these criteria that I want to have in my end-to-end machine learning platform. So it's an open source project that contains a curated set of tools and frameworks for machine learning workflows on Kubernetes. And the Kubernetes is the key word here because that kind of gives us bunch of the features that we see here. So because it's running on, so Keyflow is scalable, composable, portable, is open source, is industry supported, and it's multi-tenant. So you can have the same Keyflow environment you can use for the entire team, give them individual spaces, and so you can run your experiments in an environment that is going to be very close to what your final destination of that product or project is. So scalable is built on top of Kubernetes, so scalability is built in. You can get scalability of the pods. You can also get the scalability of nodes. So depending on your installation of Kubernetes, if you are doing it yourself or using a managed Kubernetes, you can scale your Kubernetes to any number of pods to some reasonable amount. And also because it's built on top of Kubernetes, and Kubernetes has existing pool of skilled individuals that knows how the infrastructure works. So you have either you already are using Kubernetes for other things in your company, or it is fairly easy to find folks with skills on Kubernetes. So you can also think of using Kubernetes as a means of scaling your teams that needs to use this platform, right? You can easily find talent rather than if you're building something very custom in-house, you would have a harder time finding people that just knows the system. You'll have to hire someone, train them on the system. So you're spending a lot of cycles on building skills up, where in this system you already have people that just know Kubernetes already. And also hopefully by virtue of Keyflow being an open source project, a lot of people would also know Keyflow as a system. Composable, so going back to this slide, Keyflow has ways to manage each of those steps by using different tools under the Keyflow ecosystem. So we're gonna look at a few of them today, but composable basically means you can use different parts of the tools under Keyflow to kind of create this system that covers all of these things that we want in an end-to-end machine learning platform. Portable, so Keyflow, you can use Keyflow from local to training environment, or from training environment to cloud, or from cloud to cloud. And your environment of Keyflow underneath stays pretty much the same. So we like to think that when you're running experiments on your local machine versus when you're running your training versus when you're running your cloud deployment, it kind of looks the same, right? Like this is what we want to happen. But usually what ends up happening is that our experiment environment is much smaller in scope. We are just like running maybe a Jupyter notebook or one Python file. And then in our training environment, we are running that, but in a much beefier machine with GPU and other resources. Finally, we go to cloud. Now we are dealing with like a lot more things. Like we're dealing with IAM permissions. We're dealing with models. We're dealing with canary deployment, rollback, rollouts. So our environments ends up looking a lot different when you are just like doing it ourselves. And although we would like to think like, okay, we have deployed it ourselves and we have tested it, the model works, but every single minor differences in each of our environment would end up leading us to getting into some outages, right? Like, because we probably haven't covered the differences between our experiment stage versus our staging and our cloud. And each of those differences ends up turning into something bigger later on. Because machine learning is no longer a novelty. Machine learning is a core part of our business. And machine learning is no longer just research, right? We have to use machine learning now, get true insight into our business to be able to stay ahead of the curve. If you're not, so machine learning used to be something that you used almost as like getting an advantage now. Before, now machine learning is what you have to use to stay with the curve because everyone else is using it too. So it's part of the core business. So we quality control our software. We make sure that our software is not regressing from version to version. Then we need to actually quality control our machine learning artifacts as well. We can't just build the model on our local laptop and just deploy it into production just by copying some files over. That's not how we can, that's not how we do software, and that's not how we can do machine learning either. So with Keyflow, you can have a local environment of Keyflow just in your laptop or in a dev Kubernetes cluster somewhere. You could have a training environment with GPU also running Keyflow. And finally, you can have the deployment Keyflow also in the cloud. And now you have kind of limited the number of differences between your experiment training and cloud environments because all of them are underneath using Keyflow. So this makes your environment pretty identical to each other and thus making your environment portable. These are some of the Keyflow components we usually talk about. So you have, first of all, you have the platforms, you have your clouds. It could be on-prem Kubernetes or local Kubernetes or any of the cloud providers. On top of that, you have Keyflow application. There are a lot of names here. We're not going to be talking about all of them today, but some of the key things are here. We have Istio as the network layer. We have Argo or Tecton as pipelines. So if you want to build Keyflow pipelines, you use one of those things. For machine learning tools, you have Jupyter Notebook, MPI, MXNet, TensorFlow, PyTorch, XGBoost, and all these other things. So another view of the components. So very first thing we have on Keyflow is a dashboard that lets us look at all the things that are on our Keyflow environment right now. Next, we have Jupyter Notebooks. And as of the latest version of Keyflow, we have also a bunch of other server there as well, like Code Server or RStudio. We have some of the machine learning frameworks like TensorFlow, XGBoost, PyTorch. For pipeline, we have choice of Tecton or Argo. For serving, we have Seldon, or we have KF serving. For machine learning metadata, we have MLMD. For feature store, we can use Feast. And for monitoring, because it's running on top of Istio, we can make use of Prometheus and Grafana dashboards to look at what's happening in a cluster, as well as monitoring other models as the traffic routing is happening. So if you want to deploy Keyflow today, you can head to the manifest repository and you can use customize and kubectl. That's the latest, most recent instruction on how to install Keyflow. And you can use that to install Keyflow on your Kubernetes cluster or your local machine and Minikube. So manifest repository is structured in a way now where it's easy to kind of find what are the extra apps, what are the common things in Keyflow, and what are the contribution from the community to Keyflow. Back in about 2 weeks ago, when 1.2 release was the main release of Keyflow, the repository was a little bit more cluttered. We had a lot more things on the top level, so it was difficult to navigate. But with the new 1.3 release, we have improved some of the Keyflow deployment strategy by changing up the order of the repository. So again, if you looked at Keyflow before, this is what it used to look like on the left, the structure. With the latest release, we kind of went through and changed many of the structure by restructuring the things around It still does the same exact thing, but it's just restructured to do things a little bit more cleaner. So how can this help? So goal is to improve accountability for maintaining component manifest, increase modularity. You can pick and choose the tools you want to install pretty easily. And we want to make sure the deployment experience is smoother. So first-time users, you should have a much smoother experience if you had tried Keyflow in an earlier time. You can also use Keyflow Operator. So you have the operator that you can make use of. And Kubernetes Operator is built so that we have an easier time deploying Kubernetes resources. So again, I'm going to just skip through the operator part for a second because you can use the Kubernetes operator, Keyflow operator to deploy Keyflow to Kubernetes or OpenShift, and you have documentation here about it here. But one thing I want to mention, Keyflow is an open source project and it's not all sunshine and rainbows. Some of the difficulty with Keyflow is that because it's open source and it's rapidly growing, there are definitely a lot of growing pains that we see. Because underlying components that are, a bunch of them are also open source and have their own release cycle. So you have some challenges there, right? Keyflow has many moving parts. Each component has their own release cycle and upgrade path. So as a Keyflow, if you're maintaining Keyflow as a distribution for your company, it is going to be something, at least at this point, it's quite a big challenge right now. And we are, as the Keyflow team, trying very hard to make sure that doesn't usually happen. And for the most part, as an individual end user of Keyflow, you don't really see a lot of these problems. But as a maintainer, we see that quite a lot where underlying component is updating. We have to update all of that to make sure we're in the latest version and we're using the greatest and the latest changes into those underlying changes. So each of the platform on Kubernetes, right? Like if you're using from Azure, from IBM, from AWS, from GCP, each of them has like small differences that kind of add up into the overarching Keyflow deployment. So if you are using Keyflow on Minikube versus you want to move your Keyflow deployment to AWS per se, it might not be the exact one-to-one change as we like it to happen. But for the most part, it is still very similar to how you would use Keyflow on your local machine versus on cloud. The future, so the Keyflow 1.3, well, I'm saying will here, it is already here. It already released about 1 week ago, and all the distributions like IBM and AWS and GCP right now are testing to validate that it works on the newest release. So if you're looking at Keyflow in about a week's time, you should be able to go and use the 1.3 Keyflow on your favorite cloud platform. And because the manifest repo is being restructured, it's much easier to navigate. Okay, so some of the references, if you want to try out Keyflow, please go to Keyflow manifest. And if you want to join the community for the Slack, for other mailing lists, you should go to keyflow.org/doc/about/community. And you can learn more about the operator framework and how Keyflow Operator can improve our quality of installing Keyflow. But before we finish, I want to quickly show you the Keyflow environment. So I have a Keyflow deployment on IBM Cloud, and I'm using App ID as an authentication mechanism. By default, Keyflow comes with DEX as an authentication. So I'm authenticating against the Keyflow environment. And once I have authenticated, I would be here into my Keyflow. This is the Keyflow dashboard you would see for the first time you come into. And on the left side, you can see some of the tools Keyflow has. And I have some of the notebooks created. And the notebook servers, as of Keyflow 1.3, as we said, we have the VS Code code space here, as well as RStudio, as well as Jupyter Lab here. So again, you can, and this is namespaced by per user. So right now, I am logged in as my email here. I can also log in with a different email account with my Google. So once I do this, once I log in, it will ask me to create a new namespace. And once I do that, now I am on the same cluster. I'm a different namespace now. So if I go to notebooks, the other notebooks was for the other user, and they're not here. So on the same Kubernetes cluster, you could have multiple of the team members working simultaneously together next to each other. I'll actually go back to the other user because I had some things more to show on that other user. Here, I would also have experiments that I can run. So I have run one experiment. It's a simple pipeline, and this does like a coin flip and test condition based on something. You can define your pipelines using a Python DSL, and it will run that pipeline as KFP Tekton. You can use that to build your model, and then use KF serving to serve that model and get the full pipeline of data ingestion, data validation, and then create the model, then serve the model, and then use Istio to monitor the information as your traffic gets routed to your model and traffic gets served by the model. You also have Cadib for hyperparameter optimization. If you want to do some of that, you have that option as well. We also have PyTorch, MXNet, and XGBoost installed in this. So in pipelines, we can make use of those platforms to build our models in many ways. So we are just about over our time, and we would go back. I will end my talk here. And if you have more questions and you want to chat more about just Keyflow and have questions, or just like want to learn more, we're gonna, I think, go to the spatial chat where we can have like a side hallway track. So hopefully we get to, I'm more than happy to have some more conversation there about it. And so again, Keyflow is open source, so you can try it out and have issues. And we, as a community, we can build an end-to-end machine learning platform that works on Kubernetes for all of us. Thank you.